ultrasound examination of superficial structures. And of course, the addition of Doppler ultrasound can give valuable information regarding the vascularity of the lesions. Ultrasound is a relatively cheap and completely non-invasive method and harmless examination. The only disadvantage is that it is heavily operator dependent. Multi-detector CT with multiplanar reformat and volume ranging capabilities have really changed the way we look at CT, in which there are no non-ionizing radiations. What we use is a magnetic gradient. And just to give you, an idea of what sort of magnetic field we are using 1.5 Tesla. 1 Tesla is 10,000 Gauss, and the Earth's magnetic field is 0.5 Gauss. So you can imagine the amount of magnetic field that we are using here. The other thing that we use in this examination is radio frequency, the same radio frequency that you use to tune into a radio. And of course, we use these signals to generate images. It uses the free protons in the body. MRI physics is really the most complicated physics that I've had to negotiate during my career. Anyhow, it uses the free protons in the body, which are mainly come from the hydrogen atoms in water. And we use various radio frequencies in this process to produce differences in the relaxation times tissue characteristics, which are the T1 and T2 characteristics, which generate contrast in the images. I'm not going to get into that in any detail. The contrast properties that we use are the T1, T2, proton density, and stir images. Each of these looks a little bit different with regards to their water content. The only important thing on this slide is that all tissues with low water content, like cortical bone, ligaments, and cartilage, do not have enough water protons to generate a signal, and so appear entirely dark on all MR sequences. This is the only thing you need to remember from this slide. Advantages of MRI are the superior soft tissue resolution, no ionizing radiation, the multiplanar imaging capabilities, and of course there are the other two things, which is spectroscopy and diffusion imaging, which are really functional studies. I'm not going to talk a lot about them because their role in rheumatology is limited. Disadvantages, and this is again an important slide because you need to know what are the disadvantages. The major disadvantages being cortical bones are not visualized. Like I said, no water, no free water molecules, and therefore you cannot see the bones. Examination can be long and claustrophobic. Heavy sedation and GA may be required in small children, and patients with pacemakers and metallic valves cannot enter the magnet. So we'll just go on to imaging joints, and these are some of the things that you actually look at. You look at trauma, infection. These are the things that you will be coming across. So let's just talk of trauma. In trauma, the things that you look at are the menisci, the ligaments, the cartilage defects, joint effusions, bone injury, and muscle injuries. So this is, sorry, where did I go? Pointer kidhar hai isme hai? Okay, can I have a pointer, please? Acha, beech mein. Okay. This is the meniscus. You see this triangular bit here and you see that triangular bit there. That these are cross-sectional images of the meniscus. They should be black. Like I told you, there's not enough water in these images, in these structures to give you a good signal. So they should be black. But you see a bit of signal here, which is abnormal. Now this is a grade 1 tear, which is really a degenerative change. You see this here. There's a very big tear here, which is seen by this high signal. That's a tear. And similarly over here and over here. So these are meniscal tears. Tendon degeneration not only occurs with trauma, but it can occur with diabetes, with steroids, medications, inflammatory arthritis, gout, and all these things. And this is what it looks like. That's the rotator cuff, and see that complete tear there. There's a very big defect which is completely replaced by the water. The water is very bright on these images. There is another tear here which is perhaps not as complete as that, but it is big enough because you see this high signal area in there. That's the medial collateral